We're going to analyze the FRQ from the AP Stat 2009 test, question number 4. It talks about how to construct a confidence interval for two sample means. So this time we're looking at the mean response time from a northern station versus the response time from a southern fire station. So again, to do a confidence interval, we have to address state, plan, do, and conclude. When you state, you need to define your variables. We're looking at the mean response time. So that's the mean response time in minutes for the northern station. I'm comparing that to the mean response time from the southern station. Okay, so we want to estimate the mean response times between the two fire stations. The thing I put here is the mean from the north minus the mean of the south. That shows how I'm going to subtract these, and we're going to do this with 95% confidence. Guys, this is a lot of writing, but it's the kind of detail that is going to secure that you do in fact get a 4 on your FRQs. Each FRQ is out of 4 points. So that's state. Next week, go to our plans. If you are doing comparing two samples and they are matched pairs, then you must make this. The two samples are independent. If you don't mention that statement, then you have not checked all the things you need to check. Okay? If these two samples aren't independent of each other, then you really should be doing a matched pairs one sample test. Okay? Or one sample interval, where you look at the difference of the matched pairs. But these are independent. The northern station is independent of the southern station. Each of the samples is random, and this actually isn't necessary. If we're told the sample is random, we don't have to do the 10% condition, but it's not wrong either. I think it's safe to assume that 50 is less than 10% of all the calls from each station. And then we check normality. This is quantitative data. Quantitative data, as long as our sample size is over 30, then the central limit theorem states that sampling distribution will be approximately normal. Don't forget that word, approximately normal. So with conditions met, we can conduct a two-sample T interval. Guys, at this point, I'm really going to let the calculator do most of the work for me. I plug these values in, but if I go into stat test, this is a two-sample T interval. I let the calculator do the work. Okay. My first sample had an X-bar of 4.3, a standard deviation of 3.7, sample size of 50. My second sample had a mean of 5.3, a standard deviation of 3.2, sample size of 50. Our confidence level is 95%. These are not pooled. They do not have the same variances. Our standard deviations are different. We don't know anything about the population variances or the population standard deviation, sigma, so we can't use pooled here. And if you're not sure, guys, don't pool. If you don't know, just don't pool. And now I'm going to calculate this. Now, one thing the calculator does that I'm not able to do is calculate an accurate degrees of freedom. It involves a very complex formula that's not on your formula sheet because you don't need to know it. So the calculator gives me my interval. It also gives me my degrees of freedom. It's probably best that you do write that degrees of freedom on the page. That way your grader knows what degrees of freedom you were using to calculate this interval. But then, if you wanted, I would at least, if you're letting the calculator do the work, at least write the formula down on your formula sheet. Even if you don't fill all these numbers in, at least write the formula down on your formula sheet and write the interval. Okay. I went through and I did calculate this using the degrees of freedom. You'd have to use the chart to get T star, or you have to use inverse T to get T star. But I end up with this interval. Negative 2.37 is 0.37. Now, what's that mean? If I'm writing a conclusion, what does this interval mean? It means that I am 95% confident that the difference in the population mean response time, so the difference, mu of n minus mu of s, is between negative 2.37 minutes and 0.37 minutes. That the true difference in response time is somewhere between these two values. So what does that mean in part B? If I go ahead and answer part B, what does that mean here? The interval captures 0. If we were doing a significance test, 0 would have been our null hypothesis. We would have said the mean difference is in fact 0. So this interval does not support the council member's belief because 0 is in the interval, which means a plausible population mean difference is 0 minutes, meaning there's no mean difference at all.